Welcome students. In this lecture, let us look at the nonlinear support vector machine. So we know that SVM is one of the best classifiers used for all basic classification applications. However, SVM works well when your data is linear in nature. So when I say linear in nature, look at this figure where the data point of blue circles and red color squares are easily differentiable. This is linear data set or linear relationship between the data. However, our practical applications are not linear in nature. Say for example, you can look at this data. How will you classify into two halves when you have one data within the other? There is no way you can classify with the lines as we have indicated in the previous diagram. So this type of nonlinear data, they are very difficult to classify by the classifiers. However, we have a methodology in SVM by which we can also classify data of higher dimension or nonlinear representation. So how do we do that? The data set is clearly a nonlinear data set, which I have shown in the previous slide. Say you have an X and you have an Y. Now what we are going to do is, in nonlinear SVM, we are going to project our data X comma Y into another plane using any one of the relation. Here the third plane I have indicated is capital alphabet Z, and the relation I have indicated is x square plus y square. So you must know some prior knowledge, or you must have some prior information about the data set which you are going to use in your experiment. Then you can frame the relation and project it into a third plane. Now what is the advantage of having this third plane? Now look at this diagram. When you have a third axis, a 3D representation, the information which you saw one within the other in the two-dimensional space is now having sufficient gap in the three-dimensional representation. So the purple color data and the yellow color data can be easily classified with the help of your segmentation line. So this is the advantage of converting into your third dimension. However, you will have many challenges because the mathematical representation and conversion is not going to be straightforward. The radius of the data is very important, and also you need to make sure you are well versed with the relation between the two different types of data. Now you can clearly see that you have a blue color threshold line as we use in the traditional or the linear SVM, which will be able to classify the two-dimensional data. So how do we form the relation z is equal to x square plus y square? You have plenty of different types of equations which we call it as kernels. That's why we have the name kernel based SVM. Depending on the application, you can choose any one of the kernel. So the function of the kernel is to convert the two-dimensional data into a three-dimensional plane where you are going to get more efficiency when you have a nonlinear data in your hands. So the most commonly used kernels are polynomial kernel, Gaussian kernel, RBF kernel, sigmoidal kernel, and also Laplacian kernel. So these are some of the kernels and their mathematical equations. However, if you find any mathematical equation which could transform your data into another domain, then definitely you can make use of this kernel too. That's why when you look at many research papers, authors would bring different types of mathematical equations, and they say that these are different types of kernels which are used for converting data into higher dimension